Hi, so in today's video I'm going to share basically what I just kind of thought of, like I was thinking of how to what title I could create for this video and stuff like that, and I thought it's basically about a better way to view values of variables, of bash variables, whether you're working in a terminal or if you're writing a script, etc. Essentially, whenever you want to view what the value of any given variable is set to, you usually use something like echo or printf to view that value. But there's actually a better way, and that's what I'm going to share in this video. So I guess let's jump right in and see what that exactly is and what I'm talking about. The better way is essentially to use the declare built-in with the p option. And so if I, for example, set a value of variable a equals 1, and then I use declare pa, I can view the value of that variable. Like, why is this better? Let me show you kind of right away a few examples where you can clearly see that it is more beneficial than just viewing a value like this. Well, first of all, you can clearly see the name of the variable as well in the output, and that's very useful for when you're writing scripts. If I declare an array, then I can also view the contents of that array on a single line in one go. And you're probably already thinking, well, that's just is gonna be a mess if there's long values and there's a lot of elements in the array. And I have a solution for that. That's kind of the second part of what I'm wanted to show you in this video, and that's a command line tool that I wrote that allows you to view this this output of declare p and in a more readable way, and can break it up into lines and sort and do all kinds of things. So let's also just quickly take a look at another example with declare. In order to use an associative array in bash, you actually have to use declare to create it, and you do it like this: declare with the capital A, and then you can have any key with any value, both the key and the value can be any string. And so let's just create something like this. Then I just press enter, then you have an associative array, and I can view it just like this with declare p as well, and I can see all the contents. You might notice right away that it's not in order, and that's just normal because the way that associative arrays work they are unordered, so the keys can appear in any order. But that command line tool that I wrote, that I already mentioned, allows you to sort them so that it's easier to view, and it also breaks it up into multiple lines and stuff, and I'll show that stuff in a second. So yeah, for associative arrays you have to use declare to create it. You can also create all the other variables with declare as well. In order to create, so if I were to create this array b that I created, that's called an indexed array, kind of the normal array that you're used to that has integers as indices. You can create it with declare too, with the lowercase a, so that's how you would create that. And for the normal variable, it's just declare dash and then the name. So the reason I wanted to show you this is because as you might notice, this output that declare p prints actually is bash code. So if I were to take this code and run it again, it would create the exact same variable with the same values. And this can be very powerful too, because it can it can allow you to do a lot of different things. You could, for example, store these values in a file and then recreate them. This might be useful for some script that you're writing. You might also just use these values to pass values of bash variables from one script to another. Um, that might come in handy with more complex scripts that, for example, maybe you call another like another interpreter of another programming language within your bash script, but then you want that the interpreter to call yet another bash instance, and you want to transfer some data from the first bash script to like the second one. You can do this with declare like this. Just to wrap things up about declare, you can view the help for declare by using the help command. This is also a built-in command in bash. So in order to view help for any built-in command, you use the help built-in as well. So view the help for declare, use help declare, and I'll just pipe it to less so that we can scroll it more easily. And there we go. You can view the information and basically like a manual for this command. There's a lot of interesting things here, and I really recommend you take a look. Especially this section, options which set attributes, because it kind of gives you like all the information about what is possible to do with bash variables. This is kind of equivalent to having like data types in other programming languages, where you have like strings, arrays, booleans, numbers, floating point numbers, etc. In bash you don't have data types, but you can give variables different attributes. And for example, like dash lowercase a is an attribute for an indexed array, uppercase A for the associative array. You can have an integer variable. You can have a variable that has always like only lowercase letters in its value. Uppercase as well. You can use dash x to export a variable the same way you would use export and then the variable name for an environment variable. Make a variable read only, and also named references, where you can basically refer to another variable by using a different name. So like both names would refer essentially to the same bit of data. This is also pretty useful sometimes in scripts and stuff like that. Yeah, take a look at this help. It's really worthwhile to know about when it comes to bash, to using bash. So now let's take a look at this command line tool that I was talking about. Let me move this pane to the top, and I'll open the man page for this tool. It's called a pretty declare print. So like this, and basically here's the man page. It's not very long, but I will show you essentially how to use it in this video too, so that's more clear, because some things might be so I feel that sometimes it's easier to figure things out by watching someone showing you how to do it, rather than reading it and then trying to figure it out from text. So that's one of the reasons that I'm making this video. So it's on GitHub. Here's the repo for it. All the installation instructions are here in the installation section. There's one dependency that I really recommend you install, and it's called bat, which is basically a replacement for the cat command, which you're probably familiar with. But the bat allows you to also have syntax highlighting and stuff like that. It's very useful. Basically, I use it in pretty declare print to colorize, to syntax highlight the output so that it's easier to read. So actually, let me just show you. So we declared like 3 variables here, A, B, and C, and they're all like different. The first one is just a plain variable, and then there's 2 arrays, one indexed and one associative. So let's go ahead and just do pretty declare, or first, now I'm getting already into the usage of pretty declare print, so this is going to be the first way to use it, but then there's also another way. So, but what I was going to show you is syntax highlighting. So let me just go declare p, then abc. So if I just print it out, it will be like this, but I can now pipe it to pretty declare print, and if I do that, I get this output. So as you can see, we have syntax highlighting here, and it's much easier to read this way. And arrays are also broken up into several lines, and this associative array is sorted alphabetically so that you don't look at those keys in some kind of unpredictable order, but rather like this, sorted, so that it's easier to work with. So there's a lot more that that pre-declare print can do, and I'll show you how that works. But yeah, syntax highlighting, this is one of themes in BAT that I used here. I could also, so let me pull up the config file. So this theme is called Solarized Dark. If I kind of disable this option that I set for myself, because I decided to use that theme in this case, like here's the default theme, for example. It's also pretty good, but it's a bit bright, so I use this Solarized instead. But yeah, basically you can have the point is that you can have different themes for your syntax highlighting with BAT. So yeah, you can install BAT from your distributions repository on Debian. It's sudo apt install BAT. And yeah, otherwise take a look at their GitHub, and you shouldn't have any problem figuring out how to install it on your system. So yeah, let me go ahead and put the theme the way it was. And yeah, okay, so we've already taken a look at the basic usage of pre-declare print. You simply pipe the output of declare p into pre-declare print. So let's take a look on some of the options that you can that we have here, and what you can do with it. So like right now we're looking at this way of using pre-declare print. There's also this other way, which I'll explain later in this video, but right now we're taking a look at this option, this way of using it, where you pipe the output of declare p, all the variables that you want to see, you just print them out with pre-declare p, and then pipe it to pre-declare print, and then you can have the options. You can also, instead of using pipe, just a simple pipe, you can also add this and this is a different way of piping. Essentially what it does, it also pipes the standard error of declare p to pre-declare print, and that is useful for one of the options, basically, because it can also work with error messages of declare p and convert them to something that is also useful, but I'll show you that in a second. Let's just kind of set that aside for a moment, and just take a look at some of the basic options that we have here, some of the kind of the simpler ones, but then we'll get into that stuff. So let's see, let's just start here at the top. So the first option is here is -s or -S, which enables or disables sorting of associative arrays. By default it's enabled, so if you don't want them to be sorted, you can disable it, and then now the associative array is not sorted anymore. So that's one option. Now there's also -M and -M that disables or enables the breaking up of arrays into multiple lines. So if you want everything to be on a single line, maybe you have very short arrays and you don't want multiple lines, then you can do that as well. And also sorting, you can have sorting on a single line as well. So now the associative array is sorted but not broken up into multiple lines. So that's that. You can change how much indentation you have when there's multi-line output. That's a minor thing, but still, let's say like you want 8 spaces, you can have that. however many you want. So let's see. Let's take a look at these two now, bat opts and sort opts. So these essentially allow you to pass options to bat and to sort. So bat, I already explained you, is responsible for the syntax highlighting. Bat can do more things than this. It can, for example, print out line numbers. So I could use that. I could do that if I wanted to. So let's try it out. So bat opts, and then as the value you just simply pass an option string as the value. Let me see if I can remember that. I think it's style numbers. Let's see. Yeah. So now we have line numbers. Yeah, I could also like add grid for example, and then I have grid as well. So bat has a lot of like little things like this that you can use to tweak the appearance, like the output, to your liking. So I'm not gonna go into that because it's not a bat tutorial, but basically, yeah, just take a look at the manual for bat or just help. For some reason on Debian they have some weird thing that the man pages didn't get installed from apt, but basically if I use bat -h probably for help and then just pipe it to less, we have all the kind of information here as well, so that also works. I felt like there was a longer help. Maybe. Oh yeah, if you use the longer version, you get more help. So that's just kind of, yeah, that's how they did it. But yeah, also like one just like little note for Debian and Ubuntu users. Basically I think pretty much anything that uses like there is a Debian derivative might have this thing. And probably like uses apt as its package manager, might have this thing where the basically the binary for bat is not called bat but batcat instead. That is because they already had some other program there that was called bat, I guess, and you can read it about it basically here. I think they had like also an issue here. Yeah, there's a link to explaining why that is. You can read about that here. But yeah, so it might be called batcat, and if you want to just use bat, which I do, you can just create an alias like this, or a symlink or something like that. I create an alias, just bat instead of batcat. So, but enough about bat. Let's get back to pretty declare print and talk about that. So let's see. So we took a look at bat opts. There's also sort opts. So sort is a standard utility. Just take a look at man sort, and you will see all of the options. So by default, it doesn't pass any options to sort, which you can see here because it says that the default is an empty string, meaning no options. But for example, like yeah, we have like a really short array there. It's not gonna like be very visible, but maybe I can add something to it. Let's just go like C equals 333. Let me just kind of add a couple more elements to it so there's more clear what's happening there. So here's a sorted version. So if I disable sorting, this is what we get with sorting disabled. So let's try to like enable sorting, because otherwise there's no point in passing options to sort. But let's try out some let's just try like reverse order or something like that, which was, where am I? Man sort, what was it? Dash R, capital R. Oh no, it's random. Reverse is lowercase r. So sorry, I pressed caps lock and I managed to use the uppercase. But here's the lowercase, and here we get the reversed order. So yeah, so that's how you pass options to bat and to sort. So just to quickly mention one more thing about these two options, bat opts and sort opts, you might have noticed that there's these colons here that you can optionally have before the option string. You can have like one colon, two colons there, or nothing. It is explained here in the man page as well. There's a section here called colon syntax, and it essentially controls whether you append options to what you have in your, either in your configuration file or in the script itself if there's a default. In this case there is no default, the default is just no options. But whichever one is set, basically if you have something in the config file, for example I have theme solarized dark here, so by default if you don't use any colons there, it appends the options to what you have in the config file. And you can see that here, because if I do this, then the theme is still solarized dark. But if I were to use a colon, a single colon replaces everything. So essentially all of the stuff that I have in my config file or in the default value in the script itself will get overwritten, and instead this value will be used. And now two colons do what like the default behavior appending. So you might think like, why do you need two colons if you pass no colons it still appends? And the reason for that, there's also a config here, so you can actually change what it does by default, either appends or replaces. So you can change this to one means enabled, so if you remove the one it will be disabled. So by default now if I save this config it will not append but replace. So now it replaces everything. So in this case, if I had that configuration by default, I could use two colons to append instead. So I hope this makes sense. But yeah, there's also, like I said, this subsection here that explains it as well. So this is basically it for the bat opts and sort opts. So now let's take a look at some other things, which there is not a lot of. Like the last option that we haven't looked at is this filter, and there's also filter list and filter commands, and they're all related, so I'll show all of that together. So what are filters? So basically, let's check it out. Since there's this filter list command, or not command but option, let's see what that does first, just to list all the filters that we have. So you get this output, and as you can see, this is an associative array that has like, there's 4 elements there, and then there is this stuff as the value. So like if you don't recognize this, this is a sed script. Sed is a standard tool as well, so just type man sed to take a look at what it is. So you don't really have to know sed to use it, because I already have some preset filters here, but you could create your own. Yes, basically let's take a look at what these filters do. They're also explained in the man page here, and there's a description of what they do as well. But let's check it out. So basically dash filter or dash F is the option, and let's try emit values. So essentially this filter, it passes the output of declare p that we're working with through sed as well, and then it modifies it. Because maybe you don't want everything that declare p prints out. Maybe you're only interested in the names of the variables. You can do that, and that's what the emit values filter is for. You can also combine filters too, as you can see here. Like it shows that you can use a comma to combine them. Yeah, and I'll show you a combination later, but let's just take a look now at the simplify filter. So the simplify filter essentially does this. It removes the declare where it's not strictly needed. So this is still valid bash code, because you don't need it to use declare to just create a simple variable or an indexed array. So that's what it does, but it keeps this declare for associative arrays. Now the simplify all removes everything, like regardless of what it is. So the associative array in this case will also get simplified. So to keep that in mind, if you had, like, for example, declare capital AC, if you just run that once before running this code, this will run fine. But if this C has never been declared, bash will just say, like, no, that's not a valid syntax for an indexed array, which it is not. So yeah, but this is. So you can actually use like these square brackets and for indexed arrays too, but of course you must have a number there and not something else. And in this case we have something else. So yeah, so simplify all simplifies even if it's an associative array. And now this unset from error filter is this is basically where I think I actually haven't enabled by default in my config. Yeah, but I'll just set it here anyways, just for the video. You can also do the same as I did in my configuration file if you like. So basically, to use unset from error, you actually need to pass all the error output of declare p to pretty declare print. So and you do need to have some errors. So I'll just add like a d there, which has not been created. And so if I just comment out the pretty declare print part for a second, if we take a look at what declare outputs, so it outputs all of this stuff just fine, and then it encounters d, for which it prints out declare d not found, and that goes into standard error. So to redirect that standard error as well as the standard output, and to pipe all of that stuff, like both the standard error and standard output of declare p to pretty declare print, use pipe and. So if I run this now, the output becomes this. So the unset from error filter transforms this error message into this. And basically this allows you to, if you were to save this to a file and then just like source that file later on, either from your terminal or from your like in a script, wherever, it will essentially recreate these variables correctly, and it will also unset the d if it's already there. So it will essentially take care of like unsetting too. And this is also like kind of a nice way to represent an unset variable, which is also like done in a bash code that you can see with your eyes normally, like without having to like look at the error message. But yeah, so unset n, by the way, so if you take a look at help unset and then pipe it to less to make it easier to read. -n, it has to do with name named references, which is when we looked at help declare, it's this n attribute. It can basically to unset a variable that is a named reference. So for example, I can create like declare dash p, or not p, sorry, n, let's call it e equals maybe c. Let me create a named reference to c. So now I could use like I could refer to c but not use c but e instead. So like if I did this, I would get the value 111, which is c under the key AAA, but I'm referring to E here, so it's the same now for E and for C. So this is a named reference. But to unset a named reference, so if I just unset what was it, E, so this won't actually remove the unset, won't actually remove the E variable, so it will actually remove this C. So now there's no C anymore, but the E is still there. Here is like, let's run that entire thing again. You can see that the C got removed, but let me put the E there. So, but the E is a named reference and it's still there. So to remove the named reference, you have to use the unset-n and then the name of that variable, and then it does get removed. So this code basically, if it's says like if it's a named reference, remove that first, and then and also remove it if it's not a named reference. So like this is kind of the only way to do it, to take care of both possibilities. But yeah, so this is just to in case you pass like a name of a non-existent variable, it also gets converted to bash code. Okay, and so like I just remembered that that I also said that I would show you a combination of filters, which is kind of like pretty clear, but like as it is. But you can just put a comma, and maybe you wanted to also simplify it, which it can do as well. So yeah, you can pass multiple filters, and they, by the way, like since it's a sed script that gets run, I also made it so that where is that filter list? So I made it so that the order in which you pass these scripts is actually respected. So it might have actually made more sense to simplify first and then unset from error, but it doesn't really matter in this case. It takes care of it either way, but it runs them in order. So if you create some custom filters here, you can kind of keep that in mind and like create them such that like the order, if the order has some significance, it will be respected by pre-declare print. That's the point. You can also test out like a sed script by using this -e or filter commands option. So in this case, it takes the sed script as the value, but it's basically like an on-the-fly filter, a filter that's not saved to this filters associative array, but you can just test it out on the command line. And then if you want to use it again, you can add it to filters in the config file. Here is like a little sample here. You simply go filters, then your new name, and then you put that value after that. So that's just like adding the values to associative arrays. The original array is just simply here in the script itself. Yeah, here it is, just before all the default options. So that's that. Essentially, we've taken a look now at the first way of using pretty declare print. Let's now take also take a look at the second way, which which can be really helpful too. Basically, you can kind of avoid piping into pretty declare print, and you can pass the names directly to pretty declare print. And maybe you're thinking that, well, you should have like done it this way from the start, but no, there's actually a reason why I created it like in this way, so that it's like two different ways, because it's not trivial to implement. Maybe I'll mention a few things about it in a moment. Basically, the syntax is simply pretty declare print, then options, and then your variable names. So let's say like ABC, and then we get this in the output. So you might wonder, well, Alex, what are you like why do you get this output? Well, essentially, let me just explain what it does first, and then I'll explain why it is done in this way. So basically, it generates the code for that you can then execute and get your results in the same way as we did just now. So like, why does it generate the code instead of just kind of doing something like this? Well, first of all, the script cannot see the environment that you're running it in. So I couldn't do it with a script. And maybe some of you are thinking, well, Alex, you could have used a function. But the thing is, no, I couldn't, because the function already has some variables. Like once you run any function in bash, it already, for example, sets a variable called funcname, func name, which contains the name of the function. So if I were to run this script like that, like function, I couldn't. So like, let me just kind of show you whatever. I don't know if this is really necessary, but why not? So let's create a function t for test, and then let's just echo func name. Func name is actually an array, so I could even do this. Yes, a one-liner function requires a semicolon. But essentially, if I run t now, the output is t, so the name of the function. So if I were to, essentially, if I had a function called I'll just call it PDP for pretty declare print, but the name could be whatever. So let's say I implemented this instead of as a script as a function. I couldn't get the value of func name from outside it. So whenever I would call PDP, the func name would also be PDP always. So I couldn't use that, for example, to like call pretty declare print with this form from within some function. It would just always return pretty declare print as if I were to use the func name, because that func name always gets changed in the context of any given function. So if I implement pretty declare print as a function, the func name will be just like out of the window. I could never use pretty declare print to check the value of the variable func name, which means that it's just like not possible to do it like this, so that you could have a command like this or like function like this that would work for every variable. It would there would be edge cases like this where it wouldn't work. So instead of doing that, I essentially did this. Pretty declare print, and then all the names, and then that outputs the code. So you could either, now you have options, you can copy this code, for example with xclip, and then you can paste it back, and then you can run it. Or if you are sort of like you might already know where this is going, I could use eval to evaluate that code directly, and then it would work. So this usage is kind of like a little bit might be a bit convoluted in some ways, but it is really the only way to make it so that you could pass the names of the variables directly to pre-declare print. And it also isn't the only thing that it can do. It can, like some of the things this way of using pre-declare print can do. Some of the things you can't do it basically by using the first way. So let me show that. You can read about both modes. So what I was showing you in the beginning of this video is the default mode. That's what I called it. Now we're working with the names mode. So in the names mode, we pass the names directly to pre-declare print, and you don't pipe anything to it. So, and it generates the code corresponding to the default mode form, essentially. And there's different things that you can pass as names. It explains here that names could be like any of these different possibilities. So this can be very useful to check positional parameters and special parameters, and which are like positional parameters would be, I guess, let's create maybe a test script or something like that. Yeah, why not? So I'll just call it test script. User ben env bash. I'll just do ch mode on it and make it executable and open it again. So now I can just let's go like eval pretty declare print and then pass like 1, 2, 3. So if you pass 1, 2, 3 to declare p, it wouldn't work because 1, 2, 3 are not variable names. They are positional parameters, and so they're different. But I made it so that since they're not like valid variable names anyways, so there will never be a clash. So you can also pass positional parameters to pre-declare print too. And so now if I pass some values here, like this, for example, it actually outputs them. It creates basically a temporary array, and it populates it with the positional parameters that you requested. So we can also take a look at what code it generates. It generates this, so it creates an array and then prints it out. That's not all that it can do. So let's sort of, I guess, have 2 lines here or something. And yeah, so you could also pass the @ symbol to pre-declare print like this, and that will also print all positional parameters. So now we have like first the code, and then the evaluated output. I just have it there so that we can, so that you can see that. Like, let me just add like an empty line there so that it's more clear. Like this. So it generates this code, and if you evaluate this or run this, then you get this. So the difference here is that you don't need to know like how many of them you have. It will just simply print out all of them. And so like if I like, and the numbers in this case get ignored. So like if there is an @ symbol, then all the positional parameters get included. So you can also do special parameters, and special parameters are described in the bash manual. Special parameters. let's see here. So there's a number of them, a star, and then the @ symbol, which we already covered, and then the number sign, this question mark, hyphen, $sign, exclamation mark, and 0. So those are all special parameters. So if I to see all the special parameters at once, you can use the %sign, just as you used the @ symbol for all the positional parameters. And so it just prints out the values of all of them. So if, these basically contain different values that are also, yeah, like it's basically part of how Bash works. It has these special parameters that have various purposes. Like, for example, the question mark holds the exit code of the previously executed command. Like the 0, well, you basically can read about them over here. I'll just leave it at that. So special parameters are kind of both the special parameters and the positional parameters, they essentially behave like variables, but they have like names that are not like that couldn't be a variable name, but they essentially behave like variables, and the values change as Bash is working. Their values change and they show different things that are useful. So I'll just leave it at this because it's not this is not a tutorial about this. But yes, you can view special parameters. You can also just pass, like, for example, if you want it only to have the question mark, you can have only that there. And here, this is by the way important, something about the question mark variable, because basically to have a let's have something here that basically the question mark stores the value of the previously executed command, but because pre-declare print runs once and then this code gets evaluated. And essentially, if I just did this, like this 0 is actually the output of pre-declare print, so the the previous value of the question mark variable gets erased. So if I run the false command here, which always exits with 1, so that we can distinguish 0 from 1, basically I run it and I still get 0. So there's a way to get around it, and this is actually like, yeah, this is a pretty difficult thing to just kind of get around. Basically, I had to add like an option to make pre-declare print exit with a specified exit code. So that's kind of the only way. Basically, if you are checking the value of the question mark variable, always have this in your command -x and then pass the question mark. So whatever number is passed to the question mark, that will be the exit code of pre-declare print, and thus the value that that ends up being the value of the question mark variable upon this code's evaluation. So now if I run this, I get 1. I could also just create a function here just to prove that it worked correctly, like just called return status, and I'll return just the value of the first positional parameter, and then I'll run return status here, and I'll put some random number there, like 26, I don't know, for example, and then we get the 26 as the value of the question mark positional parameter. But if I didn't include this option, then it would still give 0, because that's the it just gets erased because pre-declare print already runs once. So you have to have it there for that to work. yeah, like all of these things are described in the man page as well. You can change the names of these temporary variables that get created in case perhaps they clash with something that you have in your script. But I mean, if you had a variable in your script called spec params like that with an underscore at the beginning, then it would clash. So you could rename it if you wanted to, or if you there was a need for that. This option controls whether essentially in the generated code you have this like the just the pipe or the pipe and to also pipe the errors to pretty declare print. I already covered that in the previous section where I talked about the default mode. So yeah, that just controls that. And the default value is actually, I think it's, yeah, the default is it does not pipe it. So the default is it just generates it without a pipe like this, no pipe. But I changed it in my config because I like using that filter that turns the error messages from declare to bash code. So I just set it to enabled always, so that I always have the in case there's a non-existent variable there. Then it yeah, looks like I found a little bug in the script. So it's because there's two columns there. So my filter, I guess I'll just do this. I'll see. I'll update the script by the time I release this video, but now it should be fine. So yeah, and I forgot to add this here as well, just to show what code gets generated. So like this. Okay, so let's see what else we can take a look at here. Pretty much covered all of these options. Yes, explained that. So you can take a look at this section in the man page on names mode to kind of learn more about how it works exactly and what all the different possibilities are. But I kind of explained the main principles of working with it. And actually right now I'm going to show you like a kind of a real life example of using this in a script. So this is my search and subs script, which I made videos about on this channel before. But basically this script uses multiple arrays for like different purposes, but one of them is to print statistics on the searches that the script performs. So I could use this to I could use pretty declare print in this script to debug. So let's do the first form first. So I could use declare p and let me figure out what those arrays are called. So yeah, this should do basically all of these arrays are associative, I believe, and this one, I think the last one is indexed. So we can now pipe this to pretty declare print, and we should get so like, yeah, let's run this search. Basically I'm searching for this word and I'm silencing the output because we're not interested in it, but I will show statistics, and then there's gonna be like stuff like output at the end, which is the output of that command that I just added to the script for testing. So forgot to escape like to add this backslash here because I broke it up into multiple lines. But anyways, let's just run again, and here we get the output. Stats average is not found. Oh, I just made a typo there. Averages. So so yeah, as you can see, this is much easier to debug because I can just like, because these arrays, for example, they contain different values that are displayed in this table ultimately. But if I was debugging this, I certainly would like to see them sorted in the same way consistently, like each array, because each array stores different values. Like this one stores totals, this one number of matched subtitles, this one's number of unmatched subtitles, etc. So yeah, and these are all associative arrays, so they would be like, if I were to just like disable sorting here, they would all get printed kind of, I guess, in the same order, but not sorted alphabetically, and that's more difficult to just navigate, especially if there was more values there. Like for example, here you can see that it's not sorted alphabetically, like it's N and there's P and then N again. So, but if they are sorted, it's much easier for me to find the right key that I'm looking for to debug. Yeah, and this last array is just an indexed array, and yeah, there's a lot of mess here, but even this is fairly easy if I know what it is that is going on in that program exactly. So I can kind of see what is being generated, and everything is split up into separate lines. So it's pretty easy to look at. But imagine if I were to, you know, write some kind of loop there or like whatever to just like display all the different values, like, and all the indices. It would be just like way more complicated. But here I can do it with a single command, and actually I'll show you how I can simplify this even further. This is sort of like a bit of a bonus, I guess, but it's just like a bash feature that I don't really see mentioned anywhere a lot. Basically, there's this way to, it's essentially this syntax, exclamation mark, then a prefix, and then the @ symbol. What that essentially does, it generates an array, you could say. It behaves like an array of variable names that begin with this prefix. So since all these variables start with stats here, I could actually simplify this command by, if I wanted to print out all of the variables that begin with stats. So it's $, exclamation mark, stats, and then the @ symbol, without any brackets like I would have with an array or anything, just @ I could also quote this. I don't know, I would just like to quote this because in my mind it kind of behaves like an array, and whenever I have an array I like to have quotes there, but in this case it wouldn't matter because like none of those variable names can have any like any spaces or anything, but whatever. So if I ran this, actually let's just take a look at to what it expands exactly. So before I run this, let me cancel out of that for a second. So let me just copy this, and I'll just echo it out just so that we can see what it outputs. So as you can see, all of the variables that begin with stats got printed. So now I can simply do declare p and then that, and I get probably the same output, unless there was some other variable that I forgot about that also began with stats. But essentially this is a way to just like see all of the variables that begin with a certain prefix. And this also kind of ties back to how you want to program your scripts. Like you might keep that in mind, and you might call variables in a certain way so that this you can then take advantage of this particular feature later on. So it's worthwhile to kind of systematically name them so that they have a certain prefix, and then you could use this feature as well. So so yeah, I guess this is kind of the first way of using pretty declare print here, and then the second way would be to do this and just use eval here. And I get the same output. But like this way I could also maybe just decide suddenly that I want to also let me like throw in all the special parameters too. Maybe I need something from there. And like actually in this case, just to kind of remind you that if I want to see the actual question mark variable there, then I should pass -x question mark. And so now somewhere in here I should have spec params, and all of them are there. So so yeah, and even the positional parameters, which is also pretty useful in scripts. Like whenever you create a bash script, like if the positional parameters have some significance in the script, you might want to just like see the entire, let's say, array of positional parameters at once. So I can just pass the @ symbol here. And I didn't pass anything to this command, but I believe the script internally sets those, like it essentially changes the positional parameters if you haven't passed any. Like there's a rule for that, but that's what the script does. I could also have something passed here. And let me see if I'm right about that. Yeah, it's still like adds positional. It adds positional parameters internally. It basically resets the positional parameters if there wasn't any. But I could pass some. So let me see what I have here. Let me pass just like this one subtitle file and like one more. There we go. And now we only have 2 positional parameters. So this is very useful for debugging, and this form in this case is preferable because if I want to see the special and the positional parameters, then that's the only way to do it, because if I couldn't do it with the other one. If I did like declare p1 or something, that wouldn't be understood. Here declare 1 not found. So even though it's kind of like you would think that you also use like $1 to refer to that positional parameter, but actually no, because like that's not in what in bash is called name. You can read more about this. I do recommend you take a look at this section in bash manual, because it can really clarify here shell parameters. Take a look at this, and it will really clearly explain what a name is, and what a parameter is, what a variable is. So basically have it clear in your mind what all those different terms mean, and what the positional parameters are and special parameters are, and how they're different from variables. So yeah, it's worth taking a look. It's not a long section at all, and that way you can know the kind of the actual terminology that you'll see when you, for example, read like help declare or something. All these like words like name will come up here. So I guess I'm gonna leave it at this for this video. I hope you like this new tool, and that it helps you write scripts in bash, or just when you're working in the terminal, make it easier to view the names of the variables. Definitely take a look at the declare command and kind of learn a bit more about it, and don't hesitate to use declare p to view the variable names instead of just doing like echo or printf to view their values, because there's way more information here, and it outputs valid bash code, which is excellent. And then you can also use declare print to prettify the output of declare p so that it's even more easier so it's easier to read, and you can like sort things and have syntax highlighting and all the other things that I showed you today. So yeah, this is it for this video. Thanks for watching. I hope you found this interesting and valuable, and I will see you in the next one.